I'm Nurlisa binti Hamzan, and the rest is Ecotribo Innovators team members. Lubrication is essential in machining to reduce friction, heat, and wear between cutting tools and workpiece. However, conventional fluid cooling use large amount of cutting fluid which raise environmental, health, and disposal concern. Therefore, MQL was introduced as alternative in controlling these factors, while using of nano MQL improvised the MQL system. The issue description in current industry were environmental challenges and lack of green machining in conventional cutting fluids. Second, the limitation of effectiveness of conventional MQL, and the third one is heat generation challenges in hard-to-cut material. Therefore, the goal is to investigate the stability and thermo-physical properties and also to measure the tribological characteristic of hybrid biodegradable nanolubricant for nano-MQL application. The approach starting from preparation of hybrid nanolubricant proceed to stability and measure the thermo-physical and also tribological properties of nanolubricant. For the result of the stability, the peak wavelength was consistently observed at 319 nanometer and exhibited the maximum absorbance value. The volume concentration absorbance were plotted to prove the Beer-Lambert law, which show the absorbance is directly proportional to the concentration of substances in the mixture. 2 hours sonication time shown that the most favorable stable nanolubricant in terms of stability in UV visible. This is the visual observation of hybrid nanolubricant after preparation. And as we can see, after 30 days, the most stable based on visual observation were 2 hours sonication time for each volume concentration. The nanolubricant prepared proved it was in a very good stability condition which exceed the stability threshold of 60 mV. For thermo-physical properties in dynamic viscosity, the 0.1% volume concentration shown the highest viscosity compared to others. Same as result for thermoconductivity, maximum thermoconductivity was recorded at 0.1% volume concentration. For tribological properties on coefficient of friction, 0.1% volume concentration given the lowest COF and had improved to 34.13% of COF compared to base lubricant. For wear scar diameter, 0.1% volume concentration produced lowest WSD and had reduced by 6.02%. In relative COF and WSD prove that increasing the nanoparticle volume concentration consistently decrease COF and WSD as aligned with BM Camel study. In conclusion, hybrid SiO2 TiO2 nanoparticles were successfully dispersed in biodegradable base oil, and 2 hours of sonication give the most stable nanolubricant. The best thermo-physical performance was at 0.1% volume concentration given improvement of 4.5% and 56.6% of thermoconductivity and viscosity respectively. It was shown that a 0.1% volume concentration was found to be the most effective for machining performance. However, further research is needed for real-world long-term performance evaluation. There were some market potentials for hybrid biodegradable nanolubricant, which are sustainable alternative to conventional cutting fluids. Second, cost-effective solution for the manufacturing industry. And the third one is scalability and commercialized prospect. Finally, these are the references that inform and guided of this research work to ensure the accuracy and credibility of this research. On behalf of our teams, this brings us to the end and thank you for listening.